Hey guys, welcome back. In this lesson, we're going to talk about a continuous function and what makes a function continuous. Okay, we're going to talk about the three different types of discontinuities. So a function is continuous at x equals a if the limit from the left and the limit from the right are equal. Furthermore, if the limit from the left and the limit from the right are equal, that means the limit has to exist. The last part that you have to check is if the limit that we found is equal to that solid dark circle. Otherwise, there's going to be a whole discontinuity. If the limit from the left and the limit from the right don't equal, then there can be an infinite or a jump discontinuity. There are three types of discontinuity. One of them that results from a vertical asymptote. We call it infinite. Some people call it essential. Another one is a jump. It usually results from a piecewise function that doesn't connect. And then the hole. A hole in the graph could be removable if we fill in the hole. So a hole is a result from factoring that cancels out a denominator. So we've already seen the hole in the graph in the previous lessons. So here's a piecewise function, and I want to know if this function is continuous. So this is how we attack this problem. We say anything that's greater than -2, use me. Anything that's less than or equal to -2, use me. These are already continuous. I only care about what happens at -2. So what is the limit as x approaches -2 from the left? From the left means I have to use the less than. So let's put a -2 in here, and we're going to get basically -2 plus 3 times -2, and then we're going to get -2 minus 6, and so we get a -8. And I told you guys in the last video, I know direct substitution is not really the way to go, but it's pretty much you're putting in -2.000000001, okay? So let's put 2 from the right, -2 from the right, so we're going to put it into here, and we're going to get -2 squared, 7 minus, that's going to be 12, and then we're going to get -5. You can stop right there, because once the limit from the left does not equal the limit from the right, the limit doesn't exist. So what this is saying is when you get to -2, one answer is -8, the other answer is -5, and so therefore it's a jump discontinuity, okay? The numbers don't match. So this is not continuous. You can stop right there. What about this one here? Is it continuous at x equals -3? Well, we're going to go limit as x approaches -3 from the left. So we're going to use less than. So we got 13 minus 4 times -3 squared, 13 minus 4 times 9, 13 minus 36, and that's going to be a -23. When you go and do it from the right side, what we're going to do is we're going to put -20 plus a -3. Great. These two match, but that doesn't mean it's continuous. That just means the next step is true, that the limit as x approaches -3 in general is -23, because these match. And now you need to look for the equal sign. Fortunately, the equal sign is part of this piecewise function, part of this piece down here, and we already figured it out. So that's going to equal to -23. Since all four of these numbers match, since this is equal to this is continuous. Okay? So next one, let's do this. The limit as x approaches -3 from the left, 5 minus -3 squared, 5 minus, you get -4. The limit as x approaches -3 from the right is going to be -1 plus a -3. So that's -4. Wonderful. because those two match, the limit as x approaches -3 in general is -4. And once again, because the equal sign was part of one of the pieces, I already know the answer. All four of these match, therefore f of x is continuous. Okay, this one is a bit different, so let's check it out. We're going to do the limit as x approaches 3 from the left, and then the limit as x approaches 3 from the right. So how do we do this? This says less than 3, use me. This says equal to 3, use me. This says greater than 3, use me. So what you want to do is you want to plug the 3 in. You get an 8. That's from the left. Plug the 3 in. That's from the right. These two match. So that means the limit as x approaches 3 in general is 8. Now you need the f of 3. This time the f of 3 is different. It's not equal sign here or here. It's here. That just so happens to be 8. And this function is continuous. Okay? Here's our next one. The limit as x approaches 2 from the left. Well, pause the video, try it yourself. That's going to be 8. What about from the right? The right means greater than. So that's going to be 2 plus 6. So that's going to be 8 as well. Now, the limit as x approaches 2 exists because both numbers match. But the limit as x approaches 2 does not equal f of 2. Because what is f of 2 equal to? So that's how you write it. And you say not continuous. Okay, I hope everybody sees that. By the way, that means there's a point discontinuity. That means when you go to graph it, if I may, I'm just going to erase this. You guys can pause the video if you're jotting down some stuff. That means when you get to the number 2 and you go to the number 8, there's a hole in the graph. This looks like a parabola. I really don't care. This is a line. Great. And then there's a dark circle at 2, 6. So that's what that looks like. So that means there's a hole. When the limit exists, but it's not filled in, there's a hole. When the limits don't match, like this, -8 and -5, it means it's a jump. Okay? So here, I'm going to solve for k in order to make this function continuous. So basically, what value of k will make this function continuous? Well, in order for this function to be continuous, the limit from the left must equal the limit from the, or this, in this case, they tricked us, it's a right. The limit from the right must equal the limit from the left. So let's put 5 in here. So we get -8 times 5 plus 66 must equal 5 times 5 plus k. Basic algebra. -40 plus 66 is 26. 25 plus k. 25 plus what number makes 26? K must be 1. So all we have to do is plug in for x, and we get our answer. Same story here. Let's solve for k. Ooh, there's 2 of them. Okay, so let's put the 3 in. Let's put the 3 in. We're putting it into the x. I'm going to rewrite this as 9k equals 3k plus 12. I'm going to subtract 3k, and then k is going to equal to 2. If k is 2, this function will be continuous. Okay, one more? Sure. This function looks weird. It says, use me for anyone but 6. Use me for 5.9, 5.999. Use me for 7, 8, 6.01, 6.10. But don't use me for 6. Well, remember what we talk about with limits. Limit means what would happen when we get close to 6. It doesn't mean what happens at 6. So if you plug in the 6, you get 36 plus 12 minus 15. Okay, and then here you get 36 minus 6, and then minus 30. I hope I did that right. And then I have 36 plus 12 minus 15 over 36 minus 6 minus 30. The bottom I know is 0. The top is not 0. So let me factor out the top. Still not gonna, let's see what we can do. X plus, X minus, plus 5 minus 3. X plus 5, X minus 6. These cross off. Okay, and guess what, guys? You're left with this. Remember what happens here? There's a hole at -5 comma -8 over -11 because we substitute that back in. So that's going to be positive 8/11ths. But we're actually asking what happens at 6. 6, there's a vertical asymptote. This could never, ever, ever work. No value of k. So put no value of k will make this ever work. I hope everybody sees that. You try to put the 6 into the reduced version. And also, guys, remember, unless it's 0 over 0, it doesn't exist if there's a 0 on the bottom. Last problem. I think this one will be nice. If you plug in 5, you get 25 plus 30 minus 7. And then the same here. You get 25 plus 10 minus 35. 0 on the bottom. The top gives you a number. Let's factor. X plus 7, X minus 1. X plus 7, X minus 5. Cross these off. There's a hole at -7 comma -8 over -12. Reduce that, it becomes 4/3. Okay, or what happens, x equals 5 could never, ever, ever be fixed. Why? Because vertical asymptotes is a full-blown line, a full line just like this, and it will never, ever work. So there's no value for k. So that's what you will pick as your answer choice. I hope this was helpful. Have a great day.